Good evening, everyone. I hope I'm audible to all. So, first of all, it's my immense pleasure to welcome you all on this a week-long skill development program on artificial intelligence and machine learning in industrial engineering, organized by InnovaWorld Research Center of InnovaWorld Private Limited, which is going to conduct from November 4th to November 9th, 2024. So this event has been split in two different sessions on each day. So session 1 starting from 11:30 onwards and session 2 starting from 6:30 onwards. Mostly the 6:30 sessions are hands-on practice. So this program marks a significant steps towards equipping professionals and enthusiasts with an advanced tools needed to transform industries, solve complex challenges, and push the boundaries of innovation. As many of you are aware of InnovaWorld, so by avoiding skipping the part, because today's our main agenda is to learn what is artificial intelligence and machine learning, introductory part, and what are the softwares and how it plays a huge impact in the industry. So without much delay, let's welcome our guest of today's guest dignitaries, we can say Dr. Arunava Majumder. He is an eminent person. He has a wide background or wide experience in the field of supply chain management, and also he has a wide background in statistical approaches of solving artificial intelligence and machine learning in different sectors. So, without much delay, I request our Dr. Arunava sir to take the session. Please, sir.
Thank you very much for the introduction, and it's my pleasure to means for the invitation that uh, means you have invited me to conduct this lecture. So our today's lecture actually we are going to conduct some hands-on practice on the machine learning algorithms, and we will basically discuss in this session um, what the basic machine learning is, how many, what are the basic algorithms are there in machine learning, and means what kind of machine learnings means what are the types of machine learning, and for different types, what are the different methodology we use to solve different industrial problems. So without any delay, let me share my screen. Please confirm that whether my screen is visible to all of you. Okay. So our overview of machine learning, it means I'm starting with the basics what machine learning is. So it's a basically a branch of artificial intelligence, and here we are developing different algorithms and statistical models to compute or some numerical computations and to perform different types of jobs. But there are some basic difference between the machine learnings and the programs or the means coding. So whatever we have done. Okay, coding is different. Basically, are focused to do some specific jobs. Machine learning is also programming. We program, but this programming is some advanced programming which basically it learns from different parameters, and then it has the capability to means generate some outcomes by itself. Okay, it is not like that means in program. Suppose we are supposed to means do some particular job like addition or multiplication. Okay, or means means a printing of something. Okay, or if you have means if you have means input some parameter values, and there should be some specific outcome of that, and that specific outcomes is based on the some mathematical um, means calculations, okay, which is already defined by you. But in machine learning, there should not be any kind of pre-specified calculations. You have you put some inputs, the input parameters and the data automatically it learns by itself. Okay, so there is the learning. This is why we call it learning, outcome. There should not be any mathematical calculations behind it. Okay, so what I discuss about, that is, instead of machine learning systems learn patterns and make decisions based on the data. It means that if you are uploading some data set into some algorithms, some machine learning algorithms, so it learns first, just like a child. So you see some child doesn't know anything initially. You have to means it recognize means if you want to make the child learn something, then you have to provide some tools. Okay, so it means that if you provide some, you can see this particular this child, it is learning from different letters. Okay, so these letters are provided to the child, and the child that reads the letter and it recognizes. So after one time reading or one time learning, if we provide the same type of letter to the child, then it can automatically recognize that this is A or this is B or this is C and so on. Right? So similarly, if you have given the pen to a child, and if you have learned, okay, if you means teach the child, if the child learns that yes, this is the pen, then any type of pen with a similar type of shape if you provide, then the child can automatically recognize as this is the pen. So just like machine learning also doing the same kind of things. If you provide some data set, so from that data set it learns first. If you give the input of this kind of data set, this will be the output. If the data set, the pattern of the data is like this, then this should be the output. If the pattern is like this, then that should be the output. So uh, by means of which first it learns, then it makes a model like this, and then it will give you the specific outcome. If you provide some other data set, then it can say that yes, this should be the outcome. Okay, as it already learns from the previous data set. So the key concepts are, you have to provide some data. Without in a data set, machine learning, no algorithms are, and machine learning, you can't teach the algorithm. So it can't learn anything if you are not providing the data. Okay. The next one, algorithms. There are many algorithms are there, which are the methods that to identify the patterns of the data. Models a trained algorithm. That is, first it identifies the pattern of the data set, and then the model means itself it makes some model, some algorithms, machine learning algorithms to make some new decision. Now training, these are the different terms. Training means after providing the data set, okay, the machine learning, you need to train the model. Okay, you need to train the model. So train the model means you need to means learn. Sorry, you need to teach the model, and the model learns what is the pattern of the data, based on which it will provide the outcome for some other data sets. Next one is features, the input variables used by the model for the predictions, and the labels, the output or the target variable. Output of the target variables, it means that it may be a um, if you provide some data set, that is, let us suppose rain is the output data set. Let me provide you. Let us suppose I am giving you a data set like uh, if rain is the output and rain depends on different parameters like humidity is the first parameter, which means rain is affected by these parameters. Next one is temperature. Okay, let us suppose another wind. Okay, so let us suppose these three are the input parameters and this is the output rain. So if the humidity is 60%, temperature is 40 degrees centigrade, and wind is suppose 14 kilometers per hour, then no rain. Humidity 80%, temperature 40, wind is 20, no rain. Humidity 85%, temperature 41, wind is 3 kilometers, yes, and so on. So what is the outcome variable here? We need to predict the rainfall, whether there is rainfall, yes or no. Based on this specific, there are many means a lot of means values are also given here. I have just given you a small, very small data set with just three data. Okay, so you can see 60, 40, 14, the answer is no. 80, 40, 20, the answer is also no. 85, 41, 3, the answer is yes. So this is how many dataset, at least means there should be more than 100, 200 or 500 datasets should be there to properly train a model. Okay, so now it can identify what is the pattern, for which values of these parameters it is yes, and for which values of the parameters it should be no. So after it learns, then it can give the outcome for any other dataset. If you pass some other unknown values of humidity, temperature, and wind, then it will automatically say whether there should be rainfall or not. Okay, so this is the level. Next, the types of machine learning. So there are three types: supervised, unsupervised, and reinforced learning. So basically, since it's the first class, so first lecture, so I will generally means talk about supervised learning and unsupervised learning. Supervised is the model, means it is trained on some labeled data. Labeled data means the data set is very much organized. Okay, just like the previous one. You can see the data set here: humidity, temperature, wind, rain, everything means the key parameters and the outcome. Everything is very organized. Every value is properly given in a tabular form. Okay, so this kind of data set is very organized and it is called the labeled data set. Okay, now unsupervised learning, it is for unlabeled data set. Unlabeled means if the data, some random values are given like this, let us suppose 3, 5, 6, 9, 2, 1, 5, 3, 2, 2. Okay, this is the first, second, 3, 3, 9, 8, 6. Okay, and so on. So these are the data set. Nothing is labeled here. Nothing is given, just some random numbers are given and like this. So this kind of haphazard kind of data set is called unsupervised. Now cluster this data. What is clustering? The same type of data points should be segregated like this. So this is, you can see, this is cluster 1, this is the second cluster, and this is the third cluster. Okay, so we first need to segregate the points. Okay, so look alike points into different clusters. That is the main task. Okay, so if the data set is unlabeled, then we need to the clustering is necessary. So clustering is one of the unsupervised learning process, and classification and regression are the supervised learning process. Classification and regression, they are generally working on the labeled data set or organized data set. Okay. Another one is reinforcement or reinforcement learning. So reinforcement learning, it is a taking action in the environment. So basically it means works on some feedback. Okay. So you can see this picture, the environment, state and model agent. Okay. So environment to model agent, you need some feedback about this. So it based on some feedback it works. I'm not going to discuss this reinforcement learning because of the first class. Okay, just I need to today's class, since it is an hands-on practice, so we will do so. Very basic type of algos and very basic type of things we will discuss today. These are the examples of supervised learning. So regression is and classification. So regression, you can see it is basically used in case of the out where the in case of that data set where the outcome variable, okay, is continuous. It means some different data points are given. Just and classification if the outcome variable is discrete, okay, or categorical rather than discrete. Better to uh, means say categorical. Just like the previous example, this example, humidity, temperature, wind and rain. You can see the rain, just there are only two labels, no, no, yes, yes, like this. So it's a binary. So two categories are there, yes and no. Okay, so outcome variable is a categorical, only two with the two categories, yes and no. In this case, we have to use, there is classification. These are classification model. Okay, so like this, only two categories is used in this case. Generally, always the outcome variable is of two categories. There may be three, four, five, six categories are also there. Like here, the outcome variable is to identify some model of the engine. So three and or four models of the engine may be given based on some different parameters. Okay, so in that case, three or four categories will be there. So that is also classification problem. But what is regression? Regression, it is predictable. Like if I say the outcome is amount of rainfall, amount of rain, and the parameters, input parameters, just like humidity and temperature, wind. Okay, three parameters, values, and the outcome variable is amount of rain. What is the basic difference between the categorical rain and amount of rain? The amount of rain is, let us suppose it is, if I say is 80%, sorry, 80, temperature 40, wind is 5. The amount of rainfall is suppose 10 millimeter. Sorry, 85, 41, 3, 20 mm. Okay, 50% temperature is 30 and it is 20. Okay, 0 mm. You can see the difference between these are numeric values, and these numeric values are not predictable before. If I say only rainfall, yes, or no, yes, no. Yes, no is predictable. Either it should be yes or it should be no. There should not be any other value in between yes and no, right? But amount of rainfall, we cannot predict what should be the right amount of rainfall. That may be anything. So this kind of values are called continuous, and these values are categorical. Categorical values are generally discrete. You can see the values outcomes are outcome. What should be the outcomes? That is exact outcome is not predictable, but yes, we know it should be either yes or no. It should be model 1, it should be model 2, or it should be model 3. But exact outcome, whether what is the exact model, it is 1, 2, or 3, that I don't know. But any one of the three must be there. This is called discrete categorical value. So before starting any algorithm, we first need to understand what type of data is there. Whether it is supervised, whether algorithm supervised learning should be applicable or unsupervised learning is applicable. We need to identify that one by seeing the data set. Now the data set also, in case of means it is regression in case of supervised learning, whether it should be regression or whether it should be classification, also we need to identify by seeing the output variable. If it is continuous, we have to go for regression. If it is categorical, we should go for classification. Now unsupervised learning, I already told you, I have given the example also. If the data set is like some random points are given like this, no label data, no organization, nothing is given, not it is entirely unorganized type of points are given. So you can see point 1, 2, it is point 1, point 2, point 3, point 4, 5, 6, 7, 8, 9. Okay, so 9 points are there. Now these points are first we need to make some clusters like this. 1, 2, 3. So you have to specify how many clusters should be there actually. Okay, so it is also based on the data. Okay, after providing the data, the machine it will automatically have to understand that how many clusters should be there for the segment. So if there are three, then the points should be distributed accordingly in three clusters. If the cluster is four, then accordingly the points should be distributed in four clusters. Okay. Now come to what type of algorithms are actually present here. First one is neural networks. I think everybody know about this. Deep learning. It is means the branch is deep learning, and composed of the layers of interconnected nodes, and it will learn some complex pattern. You see that it is basically it is a specific type of methods, or it follows some algorithms based on the response of neurons. Okay, so as a receptor, neuron has some, it receives some signals, it passes through the body, and then it gives some output. Okay, exactly. Neural network, it follows the same algo or same methods which are used by the neurons. Okay, neural network had some layers, some input layer, some hidden layer, and the output layer. Hidden layer maybe consist of many layers. Okay, and so it first learns the there are some algorithms which are already predefined algorithms are there to for this learning or training process. Okay, so but keep it in mind, if you multiple times if you run this program or run the program by using this neural network, you pass through the same data set, so the output may be slightly changed in between, because It doesn't follow any particular mathematical equation, what I already told you. Okay. So particular, so every time you pass, it learns and accordingly it will give you the outcome. Okay. So what are the applications? Basically, many applications are there in optimization and means image and signal processing, autonomous navigation, UAVs, and there are many other things are there. Uh, Practical applications are there for neural network, image and signal processing, the convolutional generally image processing, not signal. Convolutional neural network is used there. Okay. Second one is support vector machine or SVM. Support vector machine is a supervised learning models. Both for classification and regression, we will use this. Okay, the application is fault detection and quality assurance in manufacturing defects or something. Okay, support vector machine is used. Decision tree, it is also very useful. Decision tree and random forest, basically the algos are different, but the random forest is basically is a branch of decision tree. Means it single decision tree sometimes may create some problems sometimes. Multiple decision trees. Okay, so basically they are interconnected. Okay, and it's a model for classification and regression both. Decision tree regressor and decision tree classifier both are used for predictive maintenance and for operational decision making. So we use the decision tree regression and classifier. GBM, okay, it ensemble the learning techniques that build models sequentially to reduce errors. Okay, so it is also used in performance forecasting, risk management, etc. Reinforcement. So basically, reinforcement learning, it is a type. It is not algorithm, I can say. So it is a type of machine learning that learns optimal action, trial and error interactions with the environment. Okay, basic reinforcement right now it is nowadays reinforcement learning very much used in different scenarios. Gaussian processes, it is a probabilistic approach that is statistical, used for regression and classification, both tasks. Uncertainty, basically uncertainty in Gaussian process means since it is probabilistic. So uncertainty quantification, it is a very much used in marketing management sectors. The market uncertainty, demand uncertainty prediction. Okay, so the Gaussian process is used there, very much used. K means is a clustering algorithm for unsupervised case. Okay, so means so to segment or segregate different data sets. So what is segregation or we by using different clusters? I already have given you some examples for that. So the basically for that segregation we use this k-mean clustering. Okay, next convolutional neural network (CNN) used in image recognition, okay, and satellite image analysis. Bayesian networks, it is also probabilistic approach. Okay, so probabilistic graphical models. So generally in reliability engineering and decision support system, basically these are the type reliability engineering cases. Okay, so we use the Bayesian or probabilistic approach there. Okay, so let me before starting the questioning, let me go for the yes. So let me now just since we will do some hands-on experiment here or hands-on means practical examples. So I use some toolbox like linear regression. Basically, what linear regression is, first let me introduce with the supervised learning. Okay, supervised learning means organized. Okay, so I will consider here the example which is having the parameter humidity, which is having the parameter wind, and having the parameter as means humidity, wind, and temperature. And the outcome is rainfall amount. Since I told you that rainfall amount, we will use regression if the rainfall, that is the outcome variable. So this is the outcome, right? This is the outcome. So rainfall amount is the outcome variable. So outcome is continuous. It means it is having some numeric values. Okay, and unprespecified. It means we don't know that what type of value should be there. It may be anything. Then we have to use regression. Okay, and these three, humidity, wind, and temperature, these three parameters are input values or input parameters. Okay, so let us suppose I am using suppose it is 80%, 80, wind is uh, 20 kilometers per hour, temperature is 35, so rainfall is, let us suppose, 10 mm. Okay, and it is 80, 15, temperature is 40, 15 mm, and so on. So first I will start means giving this example in MATLAB software. Let me open the MATLAB. Okay, so uh, let me create a data set, Excel data set. First one is humidity, second one is temperature, and the third one is wind, and the output is rainfall. Okay, just let me have some random values here. Between some random values, so I have given here. Let me use this. Temperature also, I'm giving some random values here. Remember that I am using, just for an example, for the, since I am giving you the hands-on practice, so that is why I am using the random values. you have to use some proper data set, because random values will not give you the proper outcome. Okay, actually, in practical problem, in practically, if you see the humidity, temperature, wind, and rainfall, there should be some basic means relationship between them. Okay, so we cannot use the random values here. Just for the sake of the giving an example, I'm using the random values. Okay, but you should not use the any random values like this. You have to use a proper data set by collected from any internet resources, or collected from any government resources, or weather software, weather website, like that. Okay, from Indian government or the international means any resources. So since it is temperature, let us suppose it is 35 to 45, sorry. And next one is the wind. So wind blowing, let us suppose it is we are having it wind is 5 kilometers to 30 kilometers. And the last one is rainfall. So the rainfall, I am using some values. So 83, so rainfall is, let us suppose it is 60 mm. Okay, I'm using these values because I know that means it should be some relationships. So that is why I'm not using the random values for the rainfall. So that if you use the random values, the proper model, the model actually you cannot means obtain a proper model for that. So 81, 43, and 25. So let us suppose 20. Okay, so I'm using here 24 it is. This is the, so I'm saving the data set here, and it is, let us suppose it is rainfall data set. Okay, so what we do just to means to upload this data set into MATLAB. Okay, we need to first we need to take this data set into the MATLAB file first. So let me copy this data set into the MATLAB path so that it can automatically run. So loads. So it's pasted now. Let me go for the rainfall dataset now. Yes, this is rainfall dataset. Yes, look at this. So this dataset is now imported in MATLAB. Now what I am doing, there are different ways we can import these values into the MATLAB program or MATLAB history or memory. So there are first one is column vector type, second one is matrix type, third one is cell array type, and fourth one is table type. So I generally use the column vectors because in linear regression column vectors type it is means useful. So column vectors type means each and every column will be separately stored in MATLAB memory. So first column is humidity column. So it is stored separately in MATLAB memory. Temperature, it is also stored separately. Wind also stored separately, and rainfall also stored separately. Let me give you the example for this. So if I give the import selection, import data, you can see four values: humidity, temperature, wind, and rainfall. They are separately stored here. Okay. So now again, if I go to the MATLAB, you can see here one, two, three, four here in workspace: humidity, rainfall, temperature, and wind. And each and every of the value you can see 19 cross 1 double. It means it is a double vector. 19 cross 1, it means that 19 rows and 1 column. And you see that humidity, it is having 19 values, so that is why 19 rows. And cross 1, it means only 1 column. Rainfall 19 cross 1. Temperature, it is also 19 rows and 1 column. Wind also 19 rows and 1 column. Okay. Now let me uh, others. Yes, let me save this file first. Before starting any MATLAB program or before the run the program, we have to save this by using some name. Okay. Remember that do not use, if you are using MATLAB, do not use any space while saving this file, MATLAB file, in the folder. Okay, do not use any space because then it will not recognize the file. So you can use the underscore instead of that, instead of spacing. So trial linear regression. The file is stored here. Okay, now each and every now what you see, just I am using CLC is used for the clear skin. Do not clear the memory. Clear command is do not use clear command. CLC command is just used to clear the command window only. It will not clear the memory or workspace. So do not use clear command. Clear command is to clear the workspace, or it will clear each and every memory, and all these vectors whatever we have used, means humidity, rainfall, we have means uploaded in MATLAB, everything will be vanished from the workspace and the program will not run. Okay, so that is why now I am creating, since we need to identify now what are the input parameters. We know humidity, rainfall, and temperature, these three are the input parameters. So our input parameters, let us, I am defining a vector for input, and the first one is humidity. I am copying this humidity and pasting it here. Second one is rainfall, sorry, temperature. I'm pasting it here. And the third one is wind. I'm pasting it here. Okay. So input for all input and output variables are this one. And for rainfall, I am using y as another variable, output variable for rainfall. Now our structure is ready. Input and output, every structure is ready. Now what we use another variable name which is called MDL. Just I am using it. You can use any name. So MDL, what is the linear regression model for in MATLAB, means linear regression command. To perform command to perform the linear regression is uh, just wait. Fit lm x comma y, and that's all. Now the run, I have clicked on the run button. It will automatically run. It's taking a long time to generate the value. Okay, okay, sorry, I didn't display the MDL. Look, this is the our required result. Let me also run the program again. Yes, this is our required result. Okay, so first let me explain the result. What is it? I will first of all, uh, here three independent variables are there: humidity, temperature, and wind. Okay, and the outcome is rainfall. Rainfall is the output variable. The command is fitlm is the command. If you use fitlm in a first bracket and then x comma y, x is the input variables and y is the output, and the model MDL is a variable in which the fitlm outputs are means stored, and then we display MDL and it will give you the model. So let me just explain what is the actual meaning of this. Okay, say this very carefully. First of all, if I just a bit, what is the if I the what is want to explain what linear regression is. It is basically a model that is a linear model, and linear model means an equation is created out of linear equation means the power of all the variables is 1. Okay, and basically you can see the equation type is this. And what is the equation type? Output is equal to some constant plus A1 into input 1, input 1 plus A2 into some input 2 plus A3 into input 3. Now what is input 1? Input 1 here, it is, you can see the program. Your first input is humidity. Okay. So input 1 is humidity here. Humidity. What is input 2? Let us go to the program again. Second input is temperature. So input 2 is temperature here. And what is input 3? Input 3 is wind, the speed of wind or the velocity of wind. Okay. And what is A1, A2, A3? All these are some constants. Actually, we need to identify or we need to find these values of the constant A1, A2, and A3, right? And there is another constant which is independent of all the input variables, which is the first constant. There is this one. First one, it is independent of all other input variables. So you can see this particular equation here, y. What is y? So what is output? Y means the output. Output means rainfall. Okay. So now look at this one. Intercept x1, x2, x3. Here x1 is humidity, x2 it denotes temperature, and x3 it denotes the wind. Okay. And what is the intercept? Intercept is nothing but the first constant. Okay, intercept is the first constant which does is not affected by any input parameters. Okay, so the values you can see, the equation we got, that is this is the model. So you can see the value, that is the first one, that is output, that is the rainfall is equal to, what is the intercept value? Intercept value is 78.664, that is 78.664 plus, what is the x1 value? This is the value of the x1, that is minus 0.30 or whatever next. I'm using only the first two decimal places only, into humidity plus next value is this one. This is the value 0.982. So 0.98 into temperature plus the third one is this one, minus 2.66. So minus 2.66 into wind. Okay. So this is the model. This equation actually are required to make the linear regression. This linear regression is only one type of regression process to find the regression equation. We can get a proper mathematical equation in linear regression. Okay, some other model, if you use the ANN or something, this kind of mathematical equation, there is a specific mathematical equation you cannot find. Okay, in that case, it may change, these values may change in every time you run the program. But here in linear regression, this specific model for each and every parameter values, okay, will be fixed here. Okay, now what we can do, so some other parameters you can see here. Basically, now what is the value of p value? We need to, you can see the stat AC, sorry, AC means standard error. Standard error, it should be minimized, means as much low as much as possible. The first one, the standard error for intercept, you can see it is 104. It is quite high. Okay, so for the intercept value, the standard error is not that much acceptable here. Okay, the standard error for other values, they are quite low, so we can say it is over there. Okay, Now in case of p value is must be mean and not must be for 95% confidence interval. What is confidence interval? I'm not going to discuss now because it is a very vast statistical method. You just need to remember p value, it should be less than 0.05 for a better use. So for intercept, you can see that this one, the 0.46138. It is also not okay. 0.78408. This is also not okay. 0.3 not okay. Yes, this is okay. It is 10 to the power minus 5. It is very less. So only for x3 variable p-value is very less. So we can x3 is acceptable in this case, but intercept x1, x2 are not acceptable. Okay, so these are the different parameters we can identify whether how much proper the model is and how accurate the model is. Another accuracy is R squared value. You can see R squared value is almost okay. Generally, R squared value runs between 0 and 1. As it is near to 1 or very much means approaches towards 1, 0.8, 0.9, 0.99. It is very good model we can consider. And adjusted R square value. Okay, adjusted R square value, it is 0.698. Not that much okay, but yes, acceptable you can say. Okay, now p value here, the overall p value you can see it is also less. So overall p value it is 9.16 into 10 to the power minus 5. It is okay, less than 0.05. Okay, so how to predict now? Now go to the data set again. So this is the data set. Now let us suppose the humidity, any pre-specified things now, which is not in the table. Let us suppose the humidity is 86, the temperature is 30, and the wind is 10. What should be the rainfall then? Okay, what should be the rainfall? So according to these three values, look at these three values 86, 30, and 10. This combination 86, 30, 10, this combination is not in the table. Okay, 86 value may be there in the humidity table, but the combination 86, 30, 10, this combination is missing. So for this particular combination, what should be the rainfall? This is the prediction. So just now we have to go to this equation. Okay, now for each and this equation, the value of humidity, the value of temperature, and the value of weight, you need to put it here. So this is equal to 78.664 plus 0.3 into the humidity value is 86 here. So 86 plus 0.98 into the temperature value is 30. So sorry, 30 plus minus 2.66 into the wind value. The wind is here, sorry, 10. 10. Okay, you need to calculate this one by using calculator or using the program. Whatever the value we will be getting, that value will give you the predicted value of the rainfall for 86, 30, 10, this combination. I think this is linear regression. Okay, as much as parameters, there is only we have used three parameters, that is humidity, temperature, and wind. If you want to increase or according to the data set, if there are some other parameters are used, okay, you can you have to use that parameters also into the program. Okay, and just by using, you need to, if any Excel or means a spreadsheet is there, you need to first means import that spreadsheet into the MATLAB, and then just like this you need to define the variables x and y, which are the x is the matrix of independent variables. Y is the independent variable. Use the featlm command, featlmxy, and display the model. And this model will give you already how to check the model is appropriate or not, or giving you the proper value or not. You have to test the means check the p values. Okay, you need to check the r square values, you need to check the standard error. Okay, and if you say it is according to your acceptance level, then it is okay, the model is okay. Otherwise you need to change the data set, or you need to means use some other data set, or you have to clean the data set accordingly. So this is how linear regression works. N- uh, this is a means supervised learning process. Okay, so that's all for today. Discussion. Now, if there is any question, then you can ask me.
Thank you so much, sir, for your insightful work. And you have really and truly have given an hands-on activity. And as you know, this session is completely or dedicatedly for hands-on activities. And as you have given some real-time examples of about linear regression, which is a type of machine learning. Sir, here we have few questions. Sir, like in the morning session, we have same question we had that regarding that data scarcity that we have. When we really want to work on the real-time applications, there are a lot of restrictions in the data or getting the data, or challenge of getting the data. So how can we approach, or how can we, work on those particular areas when there is a high quality of level data is scarce?
So data collection process is basically what I say. There are different ways to collect data. First, go to the internet resources. Right now, nowadays, many data sets are online available. Okay. Yes, if you require any particular data set which is not available in the internet, okay, then you need to proceed to buy or purchase the data set from different organizations where this kind of data sets they are performing or collecting this kind of data set. They sell the data, um, for some money. So you can just use some fund, or you can just purchase the data set from them, or otherwise you can perform some social experiment if according to your research work. Okay, if the research work is based on the marketing research, then it is very difficult to collect it, because some selling data for particular company they will not provide you. These are the very vital classified information or data companies are having. So they will neither sell, or they will neither give you the proper data set. Yes, sometimes in their annual report, or in the quarterly report, they provide some data, so you can use that type of data set. So in that case also you can use some magazines or some internet resources, or some news magazine from reputed news channels to collect that type of data. Or some other, if any other type of data set, any social experiment is required, you can perform the experiment by using some minimum amount of fund. Right now the Google sheet or Google form is also you can generate, and you pass those Google forms through your friends or your colleagues or your students to have some data sets. Or you can also go for the paid survey. There are many internet websites are there, we can through which you can put the questionnaires there in the means website, and you have to pay for them, or pay for
All
that.
right.
So somebody uses or fill the data, and you have to pay something to that. So paid
All
survey
right.
is also available.
Okay. Okay. Sir, we have another question. Linear regression is often chosen for an simplicity or interpretability of the work. In your experience, what is the most advantageous to use a linear regression over most complex model in practical application?
Uh, Actually, I don't understand what is the question actually. Means I can't get it. I'm sorry.
I think
Can you
so. It
please
means
explain
that
it to me?
actually, can you just give some like complex situations where linear regression has been used and have shown its accuracy? Can you give some basic examples? That is the question.
Yes, there are many papers, research papers you can find. Okay, in the industry, just recently, I can give you an example for a glass manufacturing sector. Okay, they are actually means experimenting on the melting point of the glass. So basically, glass is means consist of if a glass, it is uh, means the outcome, the last means the final product. So they use different type of materials to for different types of glass. Okay, so the amount of silica or amount of the other means ingredients in glass are not fixed for all kinds of glass. This varies. So when the means this kind of means ingredients of the glass varies, then the melting point of the glass also varies. So we collected that data set from different companies and from some other research papers, and for which type of ingredients, the amount of ingredients and the relation between the means melting point. And it is a very complex model. A lot of data is there. Thousand types of means not thousand, but it is 500 near about type of data is there. And we perform the linear regression and to predict that if different amount of material are used to create a particular type of glass, then what should be the melting point of that particular glass. It is a so it is a supervised learning process. Okay, so that is very useful. Means it means comes out to be very useful in that case. So it was a
And
practical means example what we
right,
have performed in our research paper.
right. I think this question also belongs to similar. Just let us know. Data pre-processing such as scaling can impact the performance of linear regression when working with the linear models.
Your voice is not audible. Can you please repeat it,
Okay.
or you can copy and paste the question in the chat box?
Okay, sir.
Data process pre-processing such as scaling, can impact the performance of linear regression. When working with linear models, what pre-processing steps do we just wait just a minute.
Sir, similarly, we have one more question.
Yes, you can
So,
copy and paste it here. Okay,
yeah,
just
in cases where you were extended linear regression to non-linear problems, and what are the challenges you faced, and how will you address them? Like, because when we are working on machine
yes.
learning, it's very
Okay,
difficult
so
for a
let me.
newbie to.
Sorry for the
Yeah.
interruption. Actually, there was a. Means, I didn't actually find the question. Means your voice is not means that much audible. Okay,
Sir,
so
I have
data
dropped the question in
pre
the chat box.
such as scaling. Okay, so basically, data pre if some data is not cleaned, let us suppose. Okay,
Mm.
of course, it will affect means the whatever the it is linear regression. or whatever type of means different types of algorithms you are using, of course that will affect your final result if the data is not cleaned. Okay, so
Okay.
working with the linear models, or it is linear, or whether you are using the non-linear model, the pre-processing step means cleaning of the data is very necessary. So before going to the linear models or non-linear model or any kind of, except linear, non-linear, you were using the ANN or you were using the SVM or whatever, the first step is to clean the data, process the data properly so that all the missing values or some other means values, if there is any ambiguity in the data, that can be means or means removed.
Overcome. Right.
Okay, overcome. So in that case, there are many several algorithms are there to process the data. You can also delete some rows. Okay, if the number of means cell is very limited, means missing values are limited, you can delete some cells. So deleting cells also can give you some means a proper value. You can use the average. You can use a mean or median or mode. Okay, so it depends on you what type of algorithms you will use to process that data. So only it is if any NaN value, there is not a number value or any missing cell is there, first clean the data, then go for the whatever the algos are there, you can go for that, not before that. Okay.
Right.
Next one, in case is where you have extended linear regression to.
I think they're asking whether we have to use a square matrix or mean square matrix. There are different error analysis performance, right? So, in industrial applications, which one you prefer the most, or such kind of thing?
So the matrices differ in usefulness across various. These are cases where the specific metrics are misleading. Basically, the question how do these metrics means okay, it means metrics means you are talking about the parameter means the error analysis matrices or the means
Yes, yes.
okay, okay. Okay, so error analysis matrices, these are basically to check that how the model is accurate. Okay, so in industry, these matrices are fixed. Okay, you have to check all the matrices before validating any model. If the matrices, if it matches your specified value, means you whatever your acceptance value, if the values of the matrices are means passed on means passed your specific values, then you can accept the model. Otherwise you means don't accept the model, you use some other data set to perform or to means make the model again. Okay, so the values of the matrices for error analysis are very much important, and you need to use those values to check that accuracy of the model. If it is inaccurate, use some other data set or use some maybe your data cleaning process are not that much means efficient. Use some other algorithms to clean the data set, or if you have used that kind of data set where the independent variables having some dependencies in between them, that also you have to check by using some error some other, that is which is called the correlation matrix. You may also need to identify that one by using correlation matrix. So all the matrices means other values I didn't explain today. Okay. Later on, I will explain one by one. That is, there are many matrices are present.
Okay.
Another one is linear regression to nonlinear problems. Extended linear regression to nonlinear problems. Basically, you need to check that maybe the linear fit is best, maybe the nonlinear fit is best. We cannot say that is which model is best without means see the data set, without means analyzing the data set. We have
Right.
to analyze the data set first, then we can have a prediction that yes, linear model may be the best fit or non-linear model may be the best fit. Okay. There may be
Right,
anything. You have to first
mhm,
check
right, right.
by using different matrices.
Okay, okay. I hope that your answer has given a clear clarity to our audience. And as you have said that today's agenda was too limited to linear regression, which is one type of machine learning. So thank you so much, sir, for wonderful insights or giving an hands-on activity about machine learning, how to find out. And those who are very new on this particular area, I hope they have also gone through some kind of ideas how to work on this machine learning. And definitely, I'm quite sure that they have also got to understand the basics of it. So, thank you once again, sir, for your wonderful
Thank
uh,
you very much. Thank you very much for
explanation
the invitation.
and very precise way of explaining the things. And thank you once again. See you tomorrow. Tomorrow we have one more session, session one and two. So again, sir will be taking session two tomorrow, same time, and make sure of that you are carrying your laptop and or handy equipments with you so that simultaneously you can also practice as have given the instructions. So good night everyone, good night sir, and see you
Thank you very
again
much. Good night.
tomorrow in this wonderful event. Thank you sir.